Yeah, welcome students. Thank you very much for watching this video. My little assistant here, this is the machine learning rabbit, and I will guide you through a short presentation of the Holzinger Group so that you have an idea what we are doing. So actually our topic is machine learning for health informatics. Machine learning is a very, very practical and broad field of computer science with many applications in many various domains and areas, and our application domain is health informatics. So we are a group of crazy people. We like to do crazy work, and we have a motto, and the motto is science is to test crazy ideas, but engineering is to put these ideas into business. So at the end of the day, we want to have something practical, but we start with hypothetical end user questions. So we envision the future, what could be interesting in the future. Then we start with basic science. Of course, we do some theoretical basic science, but then applied research, solving problem in the real world, and this with the aim to have at the end of this chain a customer, an end user, who is then using our equipment, algorithms, tools, methods, and so on. Okay, so these are the colleagues. So this is the crazy group of machine learning rabbits, and I will provide you a short agenda through this short presentation. At first, I will explain what is the HCI-KDD approach. Then I will very, very briefly touch the application area health. Then we will show you what automatic machine learning can do. And then my special baby and what my group is challenged is interactive machine learning. And I will give you some insight into 3 sample projects and 3 future challenges. And you know, this is the old Chinese proverb, the magical number 3. So all good things comes in 3, therefore the number 3. Okay, let's start with the first question, or to answer the first question, what is the HCI-KDD approach? As I have mentioned before, machine learning is a very practical application, but we need in machine learning a concerted learning effort. So concerted, all people work together. Of course, in the machine learning pipeline, learning algorithms are in the center of our research. But before we can apply machine learning algorithms, we have to do a lot of data science. That means data fusion, pre-processing, data mapping. And as I have mentioned before, at the end of this chain, of this pipeline, there's an end user, like you are, a human. And this human has, of course, or should be, see the results. So this is a challenging task to map the results from arbitrarily high dimensional spaces into the lower dimension. At the end of the day, into R2, what your mobile devices and your equipment is doing is presenting information on R2 in the plane. Then we are dealing with structures. Structures are very important. Structures in terms of graph, for example, and topological structures. These are both structures. And then, of course, in the medical domain, in the health domain, it is very important to deal with time. And time can be tackled via entropy. So entropy is one of our topics as well. And as I have mentioned before, our application domain is health. And if you deal in any sort with health problems, then you have a further important area, which is privacy, data protection, safety, and security. And this is a must. And this is the so-called HCI-KDD approach. This is the interactive knowledge discovery pipeline. So HCI, for your explanation, human-computer interaction, and KDD, knowledge discovery from data. Okay. But successful machine learning needs not only local concerted effort of our strengths and forces, but it needs also concerted effort internationally without boundaries. Therefore, English is our common language, and we are working in a network of international scientists from all parts of the world in a concerted effort. So this is the International Expert Network, HCI-KDD, and we tackle this problem on an international level together with a lot of colleagues and friends from the international area. Okay, I explain now our logo a little bit more into detail. So on the right side, we see the data in arbitrarily high-dimensional spaces, complex data, and on the left side, we have the human. And cognitive science is traditionally dealing with human intelligence to solve problems, for example, or to learn from data. And computer science is now, for some decades, dealing with computational intelligence. And you see, intelligence is very important. And human-computer interaction has now the challenging task of making these results from arbitrarily high-dimensional spaces visible in the lower dimension, bringing it down, mapping it down into R2. This is a huge and challenging task and needs an effort of various fields and topics. Okay, so solve intelligence, then solve everything else. This is not my motto. I have stolen this motto more or less. But if I would say it, nobody would believe me. My students would not believe me. So therefore, this is the motto of Google DeepMind, which you know well. And this is Demis Hassabis was saying this. He's the chief executive officer of Google DeepMind. Okay, our application domain is health. This is not our machine learning laboratory. This is an intensive care unit. And this is a complex area, and I briefly want to explain why this area is complex. It is mostly complex because we have to deal always with two worlds. On the one side, we have the sciences, the chemistry, the biology, the physics, the mathematics, the science of the medical sciences, the life sciences. On the other hand, you have the clinicians, the practical medicine in the hospital. And there is a gap between those two. This is a hard task to bring them together. And we have a hypothesis about it. We say, and this is our central hypothesis, information, not data, not knowledge, but information may bridge this gap. So this could be a solution to bring those two worlds together. Okay, but where is the problem in? That would be the logical question now. Where is the problem in building this bridge? The heterogeneity of data. This is a huge challenge. Then the dimensionality, as I have mentioned several times before. The complexity of the data, inherent complexity, and most of all, and this is most important, the uncertainty. We are dealing with uncertain information, and this brings us to this, what I want to teach my student at utmost importance. We are always dealing with probable information, with probabilistic information. This is our essence, and this has good aspects because we can build data, we have data, for example, a lot of data, and we can form hypotheses out of this data. And then, for example, we can calculate the prior probability, and then we can, for example, calculate or determine the likelihood of a parameter, and then we can calculate or infer the posterior probability divided through to the features, and this is in arbitrarily high-dimensional spaces, so this is a problem which is very complex. But overall, we can say we calculate the posterior by likelihood times the prior through the evidence. And this is most remarkable because the inverse probability now allows us to learn from data and to infer unknowns and make predictions into the future. And this is exactly what is the main challenge in our work. Okay, and the grand goal of the international community is automatic, making everything automatic. By myself, I want to do also having it automatic programming, for example, or envisioning automatic algorithm design and so on. But this is a big problem, and it is not feasible, let's say, in the near future that we solve these problems. And this work is a very nice example, and I have highlighted it in red, taking the human out of the loop. So this is the grand goal of the automatic machine learning community, making everything automatically, press press a button, wait for the results, this is absolutely bringing the human out of the loop, okay? And this is automatic machine learning, and I give you some examples. Recommender system. So I purchased my rucksack a time ago, and the recommender system recommended me, if you have purchased the rucksack, then please purchase also a new laptop. Go with the laptop along. And for example, the best practice is the Google car, or autonomous driving. And there are hundreds and thousands of industrial applications of automatic machine learning, and where it works neatly, perfectly, and awesome. But what you need for this automatic machine learning is huge sets of data. You need big data. So big data is nothing bad. Big data is necessary for doing automatic machine learning. As you can neatly see in this figure, you need a high number of training examples that your algorithm can learn perfectly. Okay. And my question now would be, does this work here in this area? And this brings us now to the limits. Sometimes we do not have this big data. Sometimes we have, for example, small amount of data sets, or we have rare events where we have no training examples whatsoever. And most of the time we are dealing with NP-hard problems. For example, and again the magical number 3, I pick out only 3 of the thousands of problems. Subspace clustering, which is of utmost importance in the medical domain. K-anonymization, for example, and protein folding, just to give you 3 examples, okay? And this means that sometimes we still need a human in the loop. And this brings us immediately to our baby, where we have now international recognition, interactive machine learning. So interactive machine learning, this is the definition. These are algorithms which interact with agents and can optimize their learning behavior through this interaction. So far, so good. But where the agents can also be human, but not only one human, for example, a doctor in the loop, or a biologist in the loop, an expert in the loop, also many experts in the loop, many humans in the loop, or many humans in the loop. Crowdsourcing, for example, it's an enormously interesting approach. And of course, everybody saying, this interactive machine learning is nothing new, and this is present, for example, it is supervised machine learning or semi-supervised machine learning. And I show you briefly that this is not the case. At first, we have unsupervised machine learning. This is totally automatic. You have, of course, humans at the end of the pipeline, but most of the time, or here, the human is totally excluded. In supervised machine learning, you have a human, but in front of it for labeling the data, for example, for selecting the data, but not included in the machine learning algorithm loop directly, also with semi-supervised machine learning. So our approach is interactive machine learning. That means that a human can interactively manipulate the algorithm itself and can contribute with his or her intelligence to solving a problem which would be unsolvable by an automatic approach. So this is the interactive machine learning approach, and there are, of course, a lot of research avenues open and for further research. We have here again 3 samples. For example, subspace clustering, K-anonymization, and protein design, where we have already a track record in this area. Okay, 3 sample projects from our current work. We are dealing, for example, with tumor growth simulation. In this project, we want to contribute to understand tumor growth and help to refine, reduce, and replace animal experiments, because up to date, most of these experiments are done with living animals, and you can see this cute little animal, and we don't want to harm this animal. So our, let's say, effort is to replace animal experiments by using computational algorithms, so to contribute also to save the lives of these poor animals. And This is done by machine learning, application of machine learning, and we want to go into discrete multi-agent hybrid systems with humans in the loop. Let the human do what the human can do good. Doctors are excellent in solving problems in the lower dimensions, but computers are excellent in solving problems in high-dimensional spaces. So putting them together for a concerted effort to solve challenging problems would be a main goal in the future. The next is Graphenius, the project of graph understanding. Graphs are of utmost importance in the health domain. So graph networks, for example, point cloud data are in proteins, for example. And machine learning on graphs is a hot future topic with thousands of, so if you come to me, I have immediate thousands of diploma theses for you. And for example, online graph exploration and analysis is of very high importance. And last but not least, interactive machine learning, of course, exploit human intelligence, understand intelligence, as we have mentioned before, to solve hard problems, which would be unsolvable otherwise. Yeah? And here, for example, multi-agent systems with the human in the loops, and particular crowdsourcing and gamifications is one of our topics. So serious games, gamification, making use of human intelligence is on our agenda. So this brings me to the 3 future challenges. So the first challenge is multitask learning from. This is what humans can do perfectly. Yeah, I can, for example, now think on completely different things. I can play with this rabbit. I can do something else, and so on. I can talk with you. Multitasking. This is what humans can do very good, but computers cannot do because computers have the problem of the catastrophic forgetting, and we want to help to reduce this catastrophic forgetting by multi-learn efforts. And this is immediately involved with transfer learning. That means that we have a solution and we can transfer, and this is done then automatically, no handcrafted solutions any longer, but to transfer the algorithms to solve other problems which are unsolved before with one and the same algorithm, with automatic adaptations, for example. And contributions in this area would have major impact to artificial intelligence generally and machine learning specifically. And this brings me to the last of the 3 points, multi-agent hybrid learning. That means to involve humans in the loop, to learn from both. Algorithms can learn from humans, humans can learn from algorithms. There's a high learning aspect, so also students from informatics for teachers can maybe be involved here because this is human learning involved. And this includes, of course, collective intelligence and crowdsourcing by using, for example, discrete models. So, finally, machine learning is the most growing field in computer science, and health is among the greatest application challenges. And disregarding if you like it or dislike it, it is here, it will come, and we tackle the problems. And therefore, I emphasize privacy, data protection, safety and security is on our agenda. We are tackling these problems and this seriously. So again, this is the big picture, concerted effort of our group. And this is the final slide, and I say thank you very much. Please contact me, and we will for sure find some interesting and hot topics for your future career in an international context. Thank you very much.